Hi, my dear students. Welcome to India's biggest online platform, Yummy Educational Institutions. In this session, we can solve some problems based on thermodynamics. Let's start the session. Read the question carefully. 1 gram of liquid is converted to vapor at 3 into 10 power 5 Pascal pressure. If 10% of heat supplied is utilized for increasing the volume by 1600 centimeter cube. During this phase change, this is the phase change. Generally, phase change occur at constant temperature and at constant pressure. This is the constant pressure. At this particular pressure, okay, now phase change will occur. Here, this is called latent heat. Latent heat. This is saturation pressure. Saturation. At this saturated condition, this liquid converted into vapor. Then the increase in internal energy of the process will be. First, write down the given data, then try to solve the problem. This is the question from application of first law of thermodynamics. See here, what is given? Mass of the liquid is 1 gram of the liquid. Pressure P equal to 3 into 10 power 5 Pascal. This is 3 bar actually. So 3 into 10 power 5 Pascal. At this pressure, phase change will occur. During phase change, pressure will be constant. At this constant pressure, liquid converted into vapor. And one more thing, increase in volume. Here, 10% of the heat is supplied to utilized to increase the volume. That means 10% of heat supplied is utilized to do the work. Understood now? What is the work done here? PDV work. PDV work is nothing but 10% of heat supplied. Now, work done is nothing but 10% of heat supplied. Next is increase in internal energy. What is the increase in internal energy? TU they are asking you to determine. See here, you need to know that, you should know that here what is the work done. W equals to PDV. Okay now, so this is the work done. Okay, so what is given? 10% of heat supplied, 10% of Q is given. That means 0.1 Q, 0.1 Q. W equal to 0.1 Q. Q equal to, what is Q? Tell me. What is Q? Tell me. 10 W. W by 0.1. So now we need to apply first law of thermodynamics. This is the given data. You can apply first law of thermodynamics. And before that, what is the first law of thermodynamics? What is the first law of thermodynamics? Del Q. This is del Q equals to Du plus del W. So work done and heat transfer both are inexact differentiable. So here what is given? What is given? Del Q. This would be del Q. Integral of del Q is nothing but total heat supplied. Integral of del W, you can take it as total work done. Total work done. What is the total work done here? What is the work done? I can say PDV work. PDV work. PDV work. That is the work done. What is the pressure here? I can write it as, this is the pressure, 3 into 10 to the power of 5 Pascal means Newton per meter square. What is the increase in volume? 1600 into 10 power minus 6 meter cube. Meter cube, finally you will be getting, this is how much? This is how much? Total, here you can cancel it, 10 power 5 and this and 10 power 6. 10 power 6, both will be cancelled out. Understood? Na? So now 3 into 160 Newton meter. Newton meter is nothing but 16 3 ja 48. 480 joules you will be getting. W equal to 480 joule. W equal to 480 joule you will be getting. Now I want to apply first law of thermodynamics. If you integrate it, this is the thing here. What is the heat transfer? What is the heat transfer Q? It's very simple. We already discussed that part. W equal to 10% of heat supplied, 0.1 Q. What is Q here? 10 W. 10 W. 10 W is nothing but how much? What is 10 W? 10 into 480. That means 4,800 joules. This is the heat supplied, total heat supplied. This much amount of heat is supplied, but here 10% of heat supplied is utilized to do the work. Q, basic form, Q equal to Tu plus total work done. Total work done, total heat transfer. Finally, du equals to increase in or change in internal energy. So that is nothing but Q minus W. What is the Q here? What is the Q here? 4,800 joules minus work done 480 joule. So once you subtract it, what you will get? Tell me. 4,800 minus 480. So here 4,320 joule you will be getting. This is the change in internal energy. Change in internal energy. Understood? Na? So in this manner, this is the final answer to this question. Very simple to calculate. First, try to calculate the work done. This is the work done. PDV work. Pressure is constant here. Change in volume. Here, increase in volume. So finally, 480 joules. So work done is positive here because increase in volume means work done by the system and work done is positive. So here you are getting W equal to 0.1 Q, Q equal to 10 W. Finally, we substituted everything in the first law of thermodynamics. Then you got du equal to 4320. This is the answer. Given data. What are the formula used here? W equals to PDV, pressure constant, and what is the, and one more thing, Q equal to first law of thermodynamics, du plus W. Okay na? So here du increase in increase in internal energy, change in internal energy equal to Q minus W. Q minus W. Q is nothing but 10 W. So that is the given data. Q W equal to 0.1 Q. Q equal to 10 W. Q equal to 10 W. 10 W minus W. Straight away 9 W. 9 W. What is W here? 480 joules you will be getting. 9 W. You can substitute 9 into 480 joules. Finally, 4320 joules. This is the change in internal energy. Like this also we can solve the problem. This is the way to solve this problem. This is the question from first law of thermodynamics. This question given in JEE Mains 2023 shift 1.